Hi there, Dr. Sheep here. Welcome back to TGIF Talks, episode 151. I'm your host, Dr. Sheep, joined by co-host Anonymous Phil. Hello?
Yeah.
Are you... Okay, let's just roll the intro. Too many things going on. Well, we're back on Discord. Feels like it's been a long time.
Yeah, it probably has been.
Been a very long time. So, what did you do this weekend?
Hung out with friends Saturday. Went home Sunday.
Went home Sunday. Am I the highlight? Well, I guess no. You're hanging out with your friends is your highlight, but is watching
Absolutely.
House. But is watching House the only other highlight to your weekend?
Sleeping in is always nice too.
Oh, yeah. You got to sleep in Sunday.
We'll call it a close second.
Close second?
Yeah.
Wait. A close second highlight? Or...
Yeah.
Okay. Or,
So it's third.
Oh, it's third!
Yeah, isn't that what that means?
Yes, that's what I was getting at. Yep, that is it.
It's third, but it's close to second.
Great.
Is that how I phrase it? I don't know. I don't know how to phrase it. Is it close second or close third?
Close third, I think. But I said close second as in, like, your number one highlight is that, but if we cross that out, cross the friends off, then whatever your second highlight gets moved to first.
Yeah, and so that would make it second by default, yeah.
Yeah. I had to help.
Oh.
Yeah.
What?
Well, so you got to sleep in then Sunday, right?
Yeah.
Yeah, I didn't. Grandma was...
I went to bed at like 1:30, something like that. Woke up at like 10.
Jesus.
10:30.
I guess that's 9 hours. That's normal, I guess.
Yeah. 9 hours is normal, right?
Yeah.
That's kind of what happens, You lay down and you just kind of pass out on the weekends. I guess it kind of depends how much sleep I get during the week, When I was doing night crew, I was getting a solid 8.5 hours every night. And so I didn't really have much sleep to catch up on the weekends.
Right.
But now it's like, I feel like I get 7, maybe 6.5.
I got no sleep last night. I went to bed on time, and then I just couldn't sleep. I don't think I actually started falling asleep till well after 10 o'clock. So the alarm goes out at 5:30, and the last time you checked your clock, you were only going to get 6 hours of sleep. It was a rough night. I woke. It was a rough morning. I was just like, that's not what you want. Couldn't sleep. Wasn't like, I was being kept up by my thoughts. I just couldn't sleep. Too warm.
Still got your walk in?
Yeah. Still got up. Still went and walked. I walked out. I literally opened the door. The cool air hit me and went, nope. Went back upstairs and grabbed my jacket.
Yeah.
I was just like, I probably should have checked the temperature before walking out the door. Before walking all the way down the stairs and out the door.
You can see Andromeda now. Actually, you've been able to see it for a little while.
Yeah. Well, the mornings it's You're not. I mean, not in Lincoln. You're not going to see crap. I mean, I saw another meteorite.
What do you mean? I can see Andromeda. I see it every morning when I walk out of my apartment.
You might. Oh, I guess I don't look over in that direction. I just see Orion.
Oh, no, not Andromeda. I'm talking about Orion.
Oh, okay. That makes more sense. I was just
I
like...
said Andromeda. I meant Orion.
Oh, yeah, yeah. I saw Gemini today, actually.
Oh, you know the Gemini constellation?
Mm-hmm. So I saw Gemini today. I was like, oh, there it is.
Mm-hmm.
I'm pretty sure it was Gemini. It's either Gemini or I was seeing part of Canis. But I'm...
Canis is just a line, I think.
That's Canis Minor.
Oh.
Canis Major is slightly more complex. Slightly. No, but... I don't know, just the mornings. I should have, I thought about using my telescope Saturday. Or going to the observatory. I ended up not doing either one. I ended up just sitting at home. Because I had just made black powder. And I went out and I was messing around with that. And it was just wet. And I'm just like, yeah, I don't really want to deal with that. Now I was making black powder. So I was testing. So I went to Google and I was like, all right, how the heck do I make black powder? I was expecting to make it yesterday and then make it Saturday, then test it Sunday.
Did you never learn from any of the sandbox games?
What?
Did you never learn from any of the sandbox games? Isn't it what, just saltpeter?
What? No, yeah, but you have to get the percentages right.
Oh.
And you have to grind it. Grinding is a bitch. Takes fucking forever. Hands cramp. It's not a fun process. It takes forever. I wanted to buy a blender.
Can you use a hammer?
What?
Can you just use a hammer?
No.
No?
I'm not crushing rocks. I'm crushing what's already small little things. A hammer would just make a mess and not work.
So what'd you use?
Mortar and pestle?
Oh.
I need to go buy a cheap little blender just for it. Specifically for the sulfur. The saltpeter, as I've learned, so the old way I learned was really complicated. It was a whole process, required denatured alcohol to dissolve the saltpeter, and it was honestly a very dangerous process because you had to put denatured alcohol in a pot on your stove and turn the stove on. And I'm like, what? You want me to do what with alcohol on my stove?
Turn it on.
Yeah. And then this process was just like, no, there's no need to do that. And I was comparing the two, and holy crap. It's possible I just didn't get my saltpeter, my potassium nitrate ground fine enough. I was very tired by that point after grinding freaking sulfur forever. So the sulfur was much better integrated this time than on my previous attempt. Because previously, I gave up. Because I made like a kilogram last time. And so I had to grind way more sulfur last time.
Does it smell like rotten eggs when you grind it?
I don't know. I was wearing a mask.
Oh.
You get a whiff of something, like it's just sulfur, but you're not getting rotten eggs. It's just...
Well, that's usually what sulfur smells like, is like rotten eggs.
Yeah, but it's not... So there's any smelling compound really is just... It's usually just sulfur, usually. Any bad smelling compound. And so it's more... like... I don't know how to describe it. It's kind of like rotten eggs, but not really. It doesn't smell bad. And it's not good, and it's not just content. But it's a weird. especially through the mask, you were just like, yeah, I can smell it, but you're just like, you can smell it. I was gonna burn normal sulfur. I forgot to do that for B-roll. But I forgot. I have so much goddamn sulfur, like so much, because I think when I ordered potassium nitrate at one point, they fucked up my order and they sent me sulfur instead. Like,
oh, really?
Yeah. I have so much sulfur. I have a ton of charcoal too. The charcoal was the hardest one to find.
Just buy a big bag at a hardware store.
No, I don't. I didn't want to buy briquettes and crap because it has other stuff in it.
I suppose.
And you then have to do way more work. So I just
Wait,
wanted...
is that what I ate that one time was briquettes?
Yeah. You ate part of a charcoal briquette. How does that feel?
Mm-hmm. Tastes like dirt.
Tastes like dirt. Yeah. Yeah, dirt has a lot of carbon in it. But no, it was a whole... I would rather not have to grind more than one ingredient. But in this case, I had to grind two, and you need a lot of potassium nitrate compared to the other ingredients. And that's the most expensive ingredient. It's potassium nitrate. So you're like, you need a lot of it. And so it takes forever to grind it. Well, I learned doing this that the best way to integrate it is to dissolve it in a solution and then pour the solution into your charcoal and sulfur, and then that mix it, and then you just let that evaporate off. That will integrate way better, way better, because like my old black powder performs really well. Like it's fast. This new stuff is really slow. So, but I don't think you need to heat it on a stove. I think potassium nitrate will dissolve just fine in water. But that's a future me thing. I don't know if that's going to be the part of I don't think that's going to be in the video. I was like looking at it and I'm like, okay, if I can get this black powder video like, filmed pretty much, I will have November. Well, I don't have November's done yet, shockingly, but I will have January and December's pretty much done. And then I don't have to work on the radiation. I don't have to work on a video, so the radiation box, for a while. But we'll see. We'll see what happens. So Sunday, our little cousin, she texts me.
Yeah.
She's like, I need...
yeah, because when I was driving home, I saw your truck at their house.
Yeah, she texts me, and she's like, I need help with my chemistry homework. Let me pull up what she asked. And I completely misunderstood, because I was thinking, like, way more advanced than what a little 11th grader should be being taught. So she said,
it's going to be basic.
Huh?
It's going to be basic.
Yeah, I wasn't thinking basic. So she asked, which substance can be decomposed by chemical means? Calcium, argon, sodium chloride, aluminum. Well, I was thinking, what are those? The least stable ones on there are calcium and aluminum. So I was like, calcium, aluminum. She's like, which of those two? I can only have one answer. I'm like, what the hell do you mean you can only have one answer?
Wait. Did you say, was it calcium carbonate? Or
sodium chloride.
Sodium chloride.
I was like, well, sodium chloride, the only way I thought of right away, I did actually think of a way to chemically break it down. But, it was electrolysis. I was like, that's not chemical. Yeah. But I realized this is an 11th grader. This is their first month of chemistry. This is not what the question is asking. The question is asking, which of these is a freaking compound?
Yes.
Not which of the...
which is why my mind immediately jumped to sodium chloride.
Right. Which I then realized, shit, I'm an idiot. No, it's sodium chloride. It's salt. Don't worry about it. Don't worry about what I was thinking beforehand.
Yeah.
Well, so then she calls as I'm just finishing at Grandma's, and she's like, she's asking me more questions and stuff, and then she's like, "Can you just stop at my house?" And I'm like, "Oh, I'm basically there." So I stopped, and she was doing the review for a test, which was Tuesday. She has block scheduling now, so she doesn't have class till Tuesday. So she didn't have, so like this teacher, he's a piece of shit. He assigns a study guide for a test, and then isn't going to give them time to study the study guide, which I thought was insane. He's going to go over it right before the test, and then that's it. He's not going to give them an extra day. I'm like, what is the... I'm like...
So they're going to go over it and then take the test?
Yeah.
Yeah, that's not usually how that works.
I'm like, that's a dick move. And then also, this question is horrible. This is a horrible question. Because think about it this way, right? This question it's relying on the idea that these kids.
No, I mean, I see where you're coming from.
No. My confusion. No. It actually has nothing to do with my confusion. It was with her confusion, actually, with the question, and that she had one similar to it that she didn't know how to answer, and she had to go to the teacher, and then the teacher just had to give her.
That?
Huh?
Which one was that?
It was the same one. It was asking which of these is a compound, or which of these is not an element, or whatever.
Uh-huh.
And so, my problem with the question is, all that question is saying, please look at the periodic table and figure out which one of these is not on there, and then that's your answer. Because unless you have prior chemistry knowledge, like you and I did in that class, or your prior teachers did better at teaching you. Fun fact, I actually realized it was her prior teacher that didn't teach her a damn thing in 9th grade.
I didn't really have much prior. I think I just had a good teacher, because I didn't really know much chemistry stuff going in. The only stuff I really knew was anything, not even physics related. No. Because my physics knowledge pretty much came from senior year.
Yeah, well... So I
was just another naive little 11th grader taking classes that happened to have a good teacher.
Right. So you would have been one of the kids in the class, the smarter kids in my class. Who I'm sitting there, right? And let's imagine 11th grade me had seen that question. 11th grade me would have been like, okay, it's salt, done, moved on. Wouldn't have even thought about it. Would have just been like, yep, it's salt, done, moving on. Okay. You know, I might have done the same problem. Like, what do you mean by chemically decompose? Because when I hear chemically decompose, I'm thinking, okay, this can react with something, and the only option.
No, well, I was thinking when you said chemically decompose, I was thinking like broken down. I was like breaking down an element, like what, like a bomb? What do you mean broken down?
So that's what they mean. So that's what they actually mean. But when and that's what he means, and that's the way that's the way you probably should look at it. But when I think of it, I'm thinking
obviously that's easy. It's always you're gonna need a bomb to break down argon.
Yeah, well, see, they're talking on an atomic, molecular and atomic level. I'm thinking at a physical level. Can I dissolve a chunk of calcium? Duh, it'll break down in water. It'll just break down in freaking oxygen. It'll just break down in air. Aluminum. That's a bit more difficult, but yeah, I can break that down. Salt, you just drop it in water. Okay?
Wait, hold up. Calcium, for example. Is it correct to say that it's breaking down? Oh, I guess physically it's getting smaller, but the salt is not turning into a new element. It's still salt. It's just dissolved in water.
Right. Under what? Yes. Yes, so you're right.
It's physically getting smaller, but it's still the same element.
You're right. Which is where the confusion was coming from with me. I was thinking physically, not atomically, molecularly.
Yeah, yeah.
Which is where the problem was coming from.
Well, I think the reason why,
had he not put argon on there, had he not put argon on there and put like sodium, I would have just picked sodium chloride.
Mm-hmm.
I'd been like, I would have pieced that together. It was the argon that threw me for a loop.
See, I think what he should have done, though, is that, when I took chemistry, the first thing we did, though, if I recall, was learn the elements and all their symbols. Because there's 118 goddamn, symbols, and for a little 11th grader that doesn't know the periodic table, to have to go through each... Now, I guess you could immediately shortcut it and look like, oh, there's 2 capital letters. That's 2 elements. I mean, that's a shortcut way to look at.
And that's what he needed to do, because
but when I learned chemistry, they taught us all the elements first. That way, you could know instinctively, oh, this is what all the elements were, without even having to look at the periodic table to know what the letters were.
Well, this wasn't. These were written out.
What?
These were written out, so you're going to have to look at the periodic table regardless.
Well, then they went from elements then to basic compounds and stuff.
Yeah.
And they taught me
that's what I would have preferred. I would have preferred that this teacher would have gone and been like, okay, and then written that question that way. Had done it with atomic symbols instead of their names, because now. Right. Let's say you
can look at shortcut. Oh, there's 2 capital letters. That's a compound.
Right. And I feel like you're learning now. All they have to do now, if they don't know how nomenclature works, because that you haven't taught that yet, that's not for another unit or 2. They're not gonna know. And so now they're just gonna go look at the periodic table for 10 minutes to answer the question. Like, that's dumb.
Yeah.
That's so dumb. Because, like, she had one where it was, like, name the compound, which one's a mixture or whatever, and it had, like, brass on there. And it was, like, brass and some elements. It's like, name the mixture.
Is it copper and zinc, or is it bronze?
It's, that's bronze. No, sorry, sorry. It was actually bronze. I said brass. My bad. It was actually bronze, which is just copper and tin, but,
Copper and tin.
Yeah, but
copper
brass.
And zinc is brass?
Yes.
One of them was copper and zinc.
Copper and zinc is brass.
Uh-huh.
I think. Because they call... What's... Hold on, let me... No. Bronze is tin. Bronze is tin. I know that for a fact. But they must call... It must be manganese brass is what... US dollar coins are made of. Copper plated zinc. Yeah, it's manganese brass. Okay, yeah. I thought it said manganese bronze. No, it's manganese brass. That makes more sense.
Is what dollar coins are?
Yeah, they're manganese brass. It's copper plated zinc with Sorry, no, that's the penny. No, it's manganese brass. It's 85% copper, 6% zinc, 3.5% manganese. Wow, that is a lot of manganese. Holy shit. That is a lot. Fuck. Anyways, what was I getting at? So yeah, no, I was so upset with that question. I was like, this is a stupid fucking question. Like,
I think the first thing you teach is what the hell is a mixture? What the hell is just the definition of a compound?
Right. And that's our cousin's fault. She wasn't doing a very good job with her vocab. And then there was a question.
Oh, so they did teach that. She was with vocab.
Yeah. Then there was a question. That broke my brain.
You had a horse? Broke your brain.
Question was, which of these is a homogeneous mixture?
Oh, I love that word. Homogeneous.
Okay. So here were the options. Salt, water, iron, and like, I don't know, like copper.
I'm thinking water.
That is the correct answer.
Yeah.
But it doesn't. But why? That's not a
All the
mixture.
other-
Water's a compound. That is a pure substance. What are
but
you?
It's all the bonds are the same. Salt water is not. All the bonds are not salt and water.
So, but see, so
And
the
all-
whole.
and the others
So
are solids.
my problem with that was. My problem was.
So it says mixture, so it's gonna be a liquid.
Actually, no. Actually, the definition actually turned out it could be a powder too, which defeats the purpose.
Powder is kind of powder is one of those where it's like it has the properties of a liquid because it fills the container,
Right.
but it's not really a liquid. It's a solid. It's a solid physically, but it's like a liquid because it fills the container.
They said a mixture can be at any state: solid, liquid, gas, powder.
Oh, so powder is a new state of element?
No, but they're
It's a
just
new state of matter?
they're just saying that as in, to not confuse people. Just to make sure that people understand that a powder is not a state of matter, but if you have something with a powder in it, you need to understand. And I'm like, what a fucking stupid question. Because what is stupid answers? Because none of those, in my understanding of when I was taught what a homogeneous mixture was, and maybe I misunderstand it. When I was taught a homogeneous mixture, I was under the impression that you could not separate the ingredients through decanting. You couldn't just let it settle out.
Is that if that's the definition, then I don't know.
That's what I thought the definition was, but apparently that's not the case because water is a mixture. How is that a mixture though? A mixture had to be two different substances.
It is.
But water is not.
Hydrogen and oxygen.
What? But they're bonded together. That's a compound. That's why I had such an issue with that. It's not like it's...
Well, see, when I think of homogeneous, I just think that all the compounds are the same.
See? And therein lies the issue. So they must have either changed the definition or I must have misunderstood what the definition of homogeneous mixture was. Because I was thinking, maybe I'm just thinking in the terms of mixture has to be two separate things that are not bonded together. It has to be that. But apparently, a mixture can just be fucking water. Just plain, pure water. I don't know how. I don't know why. But it is somehow. I don't understand how, but that's not for me to decide. That's for somebody higher up than me. But now, if somebody, right? Let's say you had a different question where it was like, please identify the element, mixture, compound. And you had salt, water, iron. Not salt, sorry. What's a good mixture? Brass. Okay. You had iron, brass, water. Under your previous definition, two of those are mixtures. There is no compound there.
Yes, two of them are mixtures, yes.
But water isn't a mixture. H2O is a compound.
So it says a homogeneous mixture is a gaseous, liquid, or solid mixture that has... They can't use mixture in the definition, whatever.
But therein lies the other issue.
Solid, they're using mixture in the definition. Yeah. I'm going to continue reading, but gaseous, liquid, or solid mixture that has the same proportions of its components throughout a given sample. So basically, if you zoom in, there could be a part of a saltwater mixture that has no salt bonded to the water.
No.
Right? Isn't that what that means?
No. So under this, so water can be both. in this case. I think it's kind of like a square and a rectangle almost. Okay?
Yeah.
Water alone can be a homogeneous mixture, but water cannot be a mixture. It can be a homogeneous mixture under that definition, but it cannot be a mixture. Because a mixture, I mean, unless a mixture now means that the components can be bonded, I don't know. That doesn't make any sense. Because then what the hell's a...
Oh, yeah, because then when you look at mixture... Well, yeah, cause
but if a mixture can be a solid, then this doesn't make any... None of it makes... That doesn't make any sense.
They use mixture in the definition. And it's a process of mixing or being mixed. I guess you don't mix water.
No, you don't. It's a compound. It's a pure substance. It's
a mixture composed of two or more simpler substances in chemistry. Such materials can be compounds or chemical elements.
Okay. What? Oh, components. Okay. Okay. That I can agree with.
So it's both. It's a mixture and a homogeneous mixture. A homogeneous mixture is a more, because there's two types of mixtures, right? There's homogeneous mixtures and heterogeneous mixtures.
Right. No one gives two shits. If you're making a mixture, no one's fucking making a unless we're talking food. Very rarely do you have a heterogeneous mixture.
Examples are blood, soil, cereal and milk, and ice and soda.
Of mixtures. I was thinking they were giving me heterogeneous mixtures.
That is heterogeneous. Heterogeneous examples. Oh, they also have wine, air, steel, ring.
Steel. What's their examples of homogeneous mixtures then?
No, wait, no, this has it backwards then. Because now it says homogeneous is cereal.
Oh, what in fucking Christ. This is the same crap the freaking assignment was getting wrong. If we go by what I was taught, a homogeneous mixture is something that can't be separated through decanting. You can't just let the liquid, you can't just let the solids settle out from the liquids, or you can't just pick it out easily, you know, like a salad. Salad, you can't let it sit, but you can pick out the individual components. Say, you know, cereal, you know, like if the cereal wouldn't, you know, destroy itself, the actual grain itself didn't destroy itself in the milk, then yeah. And then milk, you know, if it's been homogenized, homogenized, is a homogeneous mixture. If it hasn't been, then it's a heterogeneous, but the resulting compounds left over are then two homogeneous mixtures because you can't just decant those anymore. You could the cream you probably could. You could probably still that the cream you could probably that's just a whatever. Anyways, with a centrifuge, but anyways, it like I said, it was dumb. I'm just like, how in the fuck? Who came up with this? Who here decided?
This is interesting because one of them says steel is a heterogeneous,
and then somebody,
and the other says it's homogeneous.
They don't have a consistent definition because they fucked up.
Interesting.
So that's, I looked at her. I'm just like, I feel bad for you. I felt bad for her for that question. I was just like, I can't help you with that. I don't, on the test, if he gives you water and steel as two options on there,
yeah,
yes, you're
fucked.
You're fucked. I don't know what to tell you. I'd pick the steel, you know, personally, but apparently, according to your homework, they're both right and both wrong at the same time. So I don't know what to tell you. They don't have a
I don't
textbook.
know. Looking it up, I don't know. I just typed is steel a homogeneous mixture. This says it is. It is made from iron and carbon. A pure substance is different from a homogeneous mixture.
Right.
Because pure only has one component.
Which would be water.
No, it has two.
But see, that's my issue. Where do they draw the line? Do they draw the line at the individual?
At an element.
Okay, they draw at the element. Which then what the fuck? So the term compound is bullshit then.
Yeah, compound, mixture, same thing.
Apparently. Apparently they're the fucking same thing. According to that definition. Which, you can't teach kids that. I was taught they were two different things. Because, there was then,
So what were you taught mixture? So, wait, so what's the difference between a compound and a mixture?
According to them, there is no fucking difference.
No, what were you told the difference was?
The difference was a compound had to be broken down via chemical means.
Oh.
A mixture could be done separated mechanically or by, I mean, some mixtures you can't separate mechanically. That would be a homogeneous mixture. And homogeneous mixtures, you have to do other processes to them. But they're not bonded together. That was the difference. A mixture is a combination of things that aren't bonded together. And the difference between homogeneous and heterogeneous was heterogeneous could be separated through mechanical means. That's what I was taught. Those are much better definitions. Because it draws lines between mixture, compound, and then draws lines between heterogeneous and homogeneous. According to these definitions, there are no lines. They just draw squiggles wherever they want. I have a chemistry textbook. I wonder what it says.
Yeah, look it up.
All right, folks, be right back. This is not a college textbook, by the way. This is an actual high school chemistry textbook. Don't ask how I got it. It's a whole story. Problem is, I don't know where to frickin' start. Atomic massive elements.
Yeah, no, this stuff.
Oh yeah. I should also point out this is the chemistry textbook that doesn't just have a periodic table in it. It doesn't. Like most textbooks, the last page would be a periodic table. Nope, it's this. It's atomic masses of elements. It's a periodic table, but in like just list form, which is not useful at all. So, it's not even listed in order. Actually, it's listed in alphabetical order. That's probably why she never picked this textbook. Because...
Yeah, no, this says water is not a mixture. Therefore, how can it be a homogeneous mixture?
It can't be. Okay, let's... Mixture.
Wait, but you said her teacher said it was a mixture?
According to her homework, that was the only option. Unless it was salt.
But how do you know salt wasn't the answer?
I don't know.
Maybe salt water was the answer.
But no, it wasn't salt water. It was salt. Just salt. Sodium chloride. It fucking makes sense.
Those are still chemically, those are still a compound though.
I don't know, Phil. I don't know. The only reason why I figured out it was water is because of the stupid website you found that said water was a mixture. And then...
so you looked it up too?
Yeah. And so I said water, but it didn't make any... None of those made sense to me.
Wait, so what were the other two options?
Like elements.
Oh. But yeah, salt, how is that a mixture?
Okay. Alright. Well, it could be in different places. So let's try 58 through 60. I think that will be the best bet. 58 through 58 and 60. Ah, perfect. Okay, classifying matter according to its composition, elements, compounds, and mixtures. In addition to classifying matter according to its state, we can classify it according to its composition. This diagram. This fucking diagram literally just said exactly what I said.
Show it to the camera.
So this diagram, this one here, can you see that?
Here, bring it a little closer. I'll just take a screenshot and then look at it.
You won't be able to read it, I don't think.
Well, I just took a screenshot. Maybe I can zoom in or something.
Okay. So it starts off with matter, and it has pure substance and mixture. So pure substances, on the left, we have elements and compounds.
Okay.
Under mixtures, we have homogeneous and heterogeneous.
Okay.
Classification, matter can be pure substance. A pure substance may either be an element, such as copper, or a compound, such as sugar. A mixture may be either homogeneous, such as sweetened tea, or heterogeneous, such as hydrocarbon and water. Water is a pure substance composed of only molecules.
Oh. So I was wrong.
Fuck that teacher.
So that I was wrong and that website was wrong.
Yep. Fucking just... I knew I was fucking right. God.
So water is a pure sub... Well, that's your textbook. So what about all these other websites I'm reading?
I don't know. This is a high school textbook. Now, granted, it's not the world's greatest high school textbook. This wasn't the one we used. Ours had a periodic table in it. This one doesn't have one.
So water is a pure substance.
Yep. Let's read let's read this. Pure substances are comprised of only one type of atom or molecule. Helium and water are both pure substances. The atoms that compose helium are all helium atoms, and the molecules that comprise water are all water. The molecules that comprise water are all water molecules. No other atoms or molecules are mixed in. Pure substances can themselves be divided into two types, elements and compounds. Copper is an example of an element, a substance that cannot be broken down into simpler substances. The graphite in pencils is also an element. Carbon. No chemical transformation can decompose graphite into simpler substances. It is pure carbon. All known elements are listed in the periodic table inside the front cover of this book. Oh, that's right. It's on the front cover. Oh, but it doesn't give you atomic mass. No, yes it does. No, what? It wasn't. Why did I say I couldn't find a periodic table? This is clearly... Oh, because it's not labeled very well. It's the most basic periodic table ever. It doesn't give you states of matter. It doesn't label... It labels them into either a metal, metalloid, and non-metal.
What was the difference between a molecule and a compound?
We haven't... The same thing.
There is no difference? They use them interchangeably?
Yes. We're getting there. All known elements are listed in the periodic table in the front cover of this book and in an alphabetical order on the inside back cover of this book. A pure substance can also be a compound, a substance comprised of two or more elements in fixed, defined proportions. Compounds are more common than pure elements because most elements are chemically reactive and combine with other elements to form compounds. Water, table salt... Fuck that question. It literally had water and fucking salt as two of the options.
For what?
Her question had water and salt as two of the questions.
Re-say that sentence again.
Compounds are more common than pure elements because most elements are chemically reactive and combine with other elements to form compounds. At least on Earth, anyways. I would add that. I don't know in space if that's entirely true. I'm sure it still is, but water, table salt, and sugar are examples of compounds. They can all be decomposed into simpler substances. If you heat sugar over a pan, over a flame, you decompose it into several substances, including carbon. An element, carbon element, and gaseous water, a different compound. The black substance left in your pan after burning contains carbon. The water escapes in the air as steam. The majority of matter that we encounter is in the form of mixtures. Apple juice, a flame, a flame.
A flame?
Yeah.
Oh, hold up, a flame?
Yeah. Because air's a mixture, and a flame is just a plasma of air. Not to mention you have all your resultants from your combustion reaction. Your carbon, your water. So interesting. I guess it's true.
It makes sense, I guess.
A regular flame is a mixture. A regular flame. Now, granted, you could make a flame that's that wouldn't be a flame anymore. It would just be plasma. So I guess. Anyways, salad dressing and soil are all examples of mixtures. They each contain several substances mixed together in proportions that vary from one sample to another. Other common mixtures include air, seawater, and brass. Oh, there we go. Air is a mixture comprised primarily of nitrogen and oxygen gas.
Brass is a mixture.
Yeah, brass is a mixture. It's not a compound. Why?
They're bonded together?
No, they're not. Very few alloys are actually bonded together.
Really?
Yeah. Like, I think an amalgam is if they're bonded.
Amalgam?
Yeah, there's an amalgam and an alloy. They're two different things.
So very few compounds are actually...
Oh, sorry. Amalgam is specifically a alloy of mercury.
Oh.
Amalgam is specifically any alloy of mercury with another metal.
Oh. So then what's the other word?
Alloys.
No, but you said alloys and something else. Is there another word instead of amalgam that you meant?
Possibly. Metallic substance comprised of two or more elements as either a compound. An alloy can be in a compound or a solution. Yeah.
Wait, so brass is not a compound?
No. Truth be told, I'm sure there are some steels that are compounds and some steels that aren't. Probably. I shouldn't. Mm-hmm. I don't know that for certain. But metallurgy is, let's put this lightly here, complicated. Very complicated. On the surface, you're just mixing, two substances together in a hot furnace to see what the hell happens. But in reality, it's much more complicated. That's why I love material science. It's there's so much bullshit. Anyways, I'm sure you could find a chart somewhere, a little flow chart that describes all this quite eloquently.
Well, it sounds like we could make our own.
That's what I'm thinking. We might have to make our own chart.
Do we do it right now?
No, not now. Maybe I might have a weekend off here coming up. That isn't our trip. Possibly. Oh, we did find somebody finally.
Oh, you guys hired someone?
Possibly. She has to go through all the testing still. But we might have found somebody. So this November, I might finally get a weekend off. I'm gonna get so much and so little done all at the same time. It's gonna be great.
Yeah.
Oh my god, finally having 2 days off in a row is gonna be. Anyways, air is a compost primary of nitrogen. Seawater. Okay, it's a mixture of. Okay. All right. Air. Okay. Each of these mixtures can have different properties of its continuant compounds. For example, metallurgists vary the relative amounts of copper and zinc and brass to tailor the metal's properties to its intended use. The higher the zinc content relative to the copper content, the more brittle the brass. I guess that makes sense. Mixtures can be classified according to how uniform is the substance within the mix. In a heterogeneous mixture, such as oil and water, the composition varies from one region to another. In a homogeneous mixture, such as salt water or sweetened tea, the composition is the same throughout. Homogeneous mixtures have uniform compositions because the atoms or molecules that comprise them mix uniformly. Remember that the properties of matter can be determined by the atoms or molecules that comprise it. I should just send this to our cousin.
You should. Just take a picture of it or something.
Yeah. Yep.
Do they use the same textbook?
They don't use a textbook at all.
Oh.
They don't have one. You know, back in the day, not having a textbook meant you're poor. Now it just means that everything's digital and you're hip.
Do they have like an online book at all, or no?
Not that.
Or are they
aware.
just expected to take notes in class?
I'm not sure how it works, to be honest.
Because I guess when I was in school, did I have textbook?
I did. This wasn't it. We had a different textbook.
I don't recall. Well, the thing is that we had notes that we took. We had like a note, like PowerPoint slides that you'd print off and then you fill in the blanks or whatever. We had like a note packet that we filled out. And so I think that was our textbook, but I feel like there was a textbook, but we had to check them out. Like it was not needed for the class. But if you wanted to check out a textbook, you know, just for like a homework assignment or something, then you could. And I think that's the way physics worked too, because I don't ever remember carrying a textbook around. I think math was like the only class where I had to bring a textbook. All the other classes, it was like, oh, I needed to borrow the textbook for like a homework assignment. Otherwise, I rarely had a textbook, I think, in high school. College, on the other hand, that's a completely different story.
So yeah, that's weird. Having to check out a textbook. But no, I should probably just lend her this for the frickin' for the year. Just be like, here, this is better than whatever the hell your teacher gives you.
Oh no, we need to make our chart first.
Yeah. Well, she won't need the chart after this unit.
That is true.
But we can give it to the teacher.
No, but we want a chart because we have our just own personal desires.
Yeah. We're gonna have to do one like with alloys and crap, because like an alloy can be both.
Yeah, I was thinking like we make one that's like super complex.
Oh, great. Oh, great.
I was thinking, yeah, you can find some basic chart on Google Images.
Right.
I was thinking we make like some that's super complex.
Oh no, I'm still haven't finished that periodic table. You know.
Is that not what you had in mind?
No, I mean it is. I just never, But I'm like, is this gonna go to the realm of I never finished that periodic table, so here we are, doing another thing?
Oh yeah. Wait, you never finished it?
No,
your master, because you were gonna make like some masterful periodic table that was like beautifully color coded for like all these different things.
Yeah. Well, I was thinking about it, and I think you won't, and it needs to be like, so, because the problem with the periodic table, and this one kind of, well, this one falls into the same problem. And it doesn't address it. Like, these down here, we don't know if they're metals. We don't know. And some periodic tables, yeah, they don't label them. But the problem is, we also don't know what state of matter they are. So, you need to label that as well. But the problem herein lies is, this is still technically a noble gas. This is still technically a halogen. I was still going to ask that.
Is Organ on a noble gas? Is that confirmed?
It's a part of that.
It should be, but is it?
We don't know. I don't think we can know.
Its half-life is too short.
Yeah, that's the problem, right? We can't confirm whether it's a gas. A lot of people wonder, like, these heavier elements, do they even, act like they should? Like, if we follow this here, this theoretically might not even be a gas. It might be a metalloid. It's so heavy, it may act like a metalloid, unless it may be a solid. We don't know. Because when you look at the halogens, right? The halogens, as they become less reactive, they become solid to the point where now astatine down here is a metalloid. It's no longer just a non-metal. Because you have fluorine, which is a gas, chlorine, which is another gas, bromine, which is a liquid, and then iodine, which is a solid. But then you get so heavy with iodine, because now you have an F orbital. You didn't have F orbitals in here. These just had Ds. These two, anyways, had Ds. Now you have an F orbital introduced in there. This is just theories that I've had. I don't know if it's true. I don't know what kind of studying has been done. I don't know if anybody actually cares to figure that out.
Well, because I have looked at the color codes, and it has always interested me, It's like, yeah, if you follow the column, it's a noble gas, but if you continue the metalloid little trend you got going on, then,
But what the hell is hydrogen?
Hydrogen is a diatomic nonmetal.
Diatomic nonmetal. Okay.
Yeah, along with the other Brinkel hops.
But see, the thing about hydrogen is, though, so that's the other issue. Is the periodic table strictly in reference to nature and nature alone? Or can it be... Because we can make hydrogen, in theory, a metal.
Mm-hmm.
And, technically, at the center of Jupiter, there's liquid hydrogen. It's like a metallic liquid. It's metallic, theoretically. It acts like a metal.
It's a solid.
But if you go deep enough.
Yeah. I think Jupiter's core has literally solid hydrogen.
Right. And solid hydrogen...
Or no. Is it solid hydrogen or solid oxygen? I think it's solid oxygen.
It's solid hydrogen.
Oh, it has salt... Okay, I thought it was solid oxygen.
It actually has liquid hydrogen and then solid hydrogen, I think. Supposed to. It might be liquid helium and then solid hydrogen. I think. Solid hydrogen, though, it's a wild substance. We've tried to make it here on Earth. It's a room temperature superconductor.
What is?
Solid hydrogen.
Oh.
And it'd be a phenomenal rocket fuel. Because now we don't have to worry about trying to store gaseous hydrogen. Or liquid hydrogen, I guess. At cryo temperatures. We can store it as a solid. It'll be the most hyper energy dense. Be insane. Of course, now you have a hybrid rocket. And I don't know if you want a hybrid rocket. I don't know, because you can't. I don't think you can. I guess you can stop it in space, or you can stop a hybrid rocket from burning. Once you just turn the oxygen off, it stops. So,
yeah,
but you can't throttle it. So, it's just on off. Well, unless the amount of liquid oxygen. I don't know. But see, no one has to think about that because we don't have that substance easily available. That's the thing, right? So, like, hydrogen, most of the time, is a gas. But we can make it act like a metal.
Mm-hmm.
And stay as a metal. That's the thing. Once you pull the pressure off, it stays as a metal. It doesn't, return to gas. So, what is it? I don't know. Hydrogen, I always... with my table, I think hydrogen was just going to be a white square. It's a gas.
Oh,
it would be labeled as a gas, but it will just be a white square. So
it's not going to be included with, like, fluorine, chlorine, bromine, and all that?
No. Because it can be all of that. As a gas, it's a non-metal, but in a solid form, it's a metal. It's literally, it acts like lithium. Softer than lithium.
Solid, it acts like a metal.
Yeah. Like, what are you? That's the issue with hydrogen. Hydrogen's just complex. But for kids, I guess it kind of depends. If we're building like a periodic table meant for,
we want to build an advanced one, like one that's like as little hand wavy as possible.
Right. So hydrogen would be its own thing.
If you want a kid's periodic table, just go on Google Images. No.
Well, this is a kid's. This is as basic as a periodic table as you can get. You literally cannot make it any more basic.
Which one?
The one in the textbook.
Oh, yeah.
It sucks.
Well, how many different... Wait, they have 3 categories?
Yep.
Well, I can't quite read them. What are they? Yeah.
Non-metal, metalloid, metal.
Ah. Yep. That is probably about as basic as you can make it, yeah.
Yep. They don't even label state of matter.
Yeah. Oh, yeah.
They don't even label if it's synthetic or not, either.
Yeah. Yeah, so that is probably as basic as you can make it, yeah.
Yeah.
No, but I want to make one that is as little hand wavy as possible.
So, okay.
That's just filled with all these intricacies. So
my biggest problem...
Uh-huh.
So technetium, right? It means synthetic, right? And plutonium, we have to make it, but theoretically,
you can't find it naturally on Earth?
Theoretically you can. Atoms at a time, in the right conditions, in the right minerals, you can find technetium. Because actually, I know we've found technetium because have you ever heard of the natural Have you ever heard of the natural nuclear reactor?
No.
So there's a place in South and Africa somewhere where there's a deposit of uranium, and this water runs over the uranium, and it sustains constant fission. There's enough concentration of uranium, and the water modulates the neutrons enough to where you get fission products that you can only find in nuclear reactors. Technetium, if I'm not mistaken, is one of them.
It's called a natural nuclear fission reactor?
No, just look up natural nuclear reactor.
Oklo, right?
It's a natural fission reactor is a uranium deposit where self-sustained nuclear chain reactions occur. It was a theory, but then we found it. Locating Gibbon, yeah. Discrepancy in the amount of isotope. Normally the concentration is samples 0.6 cents difference, blah blah. Ruthenium. I thought they were finding technetium here, but I'm not sure. But I swear you can find technetium in minerals. some minerals that are radioactive, you can find it. Because I think molybdenum, if you just... What's the atomic... I have a periodic table right here. What's the atomic mass of molybdenum? 95. Never mind. Okay. I was thinking molybdenum might be 99 or like 98. So if you had a molybdenum 98 next to a neutron source and you bombard it with enough neutrons, it would turn into molybdenum 100. Sorry, molybdenum 99. And then via a beta decay, which we actually, fun fact, the only reason why I know this is because this is how we use technetium in the medical field. And to have a constant supply, we take molybdenum 99, which radioactively decays via the beta process. And when that happens, it releases an electron, and one of those neutrons turns into a proton. So you get technetium 99. So, but I think
what is that?
What'd you say?
Well, it started with molybdenum.
Yeah, molybdenum 99 radioactively decays into technetium 99, which then decays into something else via probably like an alpha process or something.
And this is used in the medical field?
Yeah, it's in your, if you grab your elements book, it's in there. If you've read it all the way through, like I have.
Well, about that.
I've read it multiple times. So.
I remember when we said we could have a book club?
We still can.
We still can, and we probably should.
Probably should. No, so yeah.
We have all the chemistry books.
We do. No, well, I have more than you, but we do, yes.
We have the Theodore Gray edition.
Yeah.
Chemistry.
But no, back to the periodic table, though. So, protactinium, technetium, neptunium, I don't know. I don't, and I think plutonium, you could probably, I don't know if you can find it in nature, but theoretically. On Earth, that's the other issue, right? In space, you could probably find plutonium. Shortly after a supernova, you could find plutonium. Hell, you could find all kinds of exotic elements shortly after a supernova.
Yeah. Well, they predict, what is it, after element 120, there's like this island of stability.
Yeah, but I thought when they reran the math, the stability meant like, you know, instead of nanoseconds, we were talking, instead of like pico and nanoseconds,
well, yeah,
we're talking
that's what I'm going to get into. It's still short-lived, like seconds, but it's seconds, not nanoseconds.
Right, which is quite a bit. We could study it. The problem is nobody's working on it. Yeah. The problem is we don't have. So we use a specific type of calcium. Last I remember, because it has a shit ton of neutrons, and then we bombard a target. The problem now is, the problem now is to get to element 119 and higher. We either A, change the composition of the target, or change the composition of our projectile. The problem with changing the composition of the projectile is that it now has a higher likelihood of not working because it's too heavy and it breaks apart when on impact with the nucleus of your target. But the problem with changing the target is we now have to make the element that we're targeting. We have to use such a heavy element that it doesn't have a very long half-life in and of itself, and it's hard to make large amounts of. that can sit there for a long period of time and be bombarded by this calcium.
Mm-hmm.
That's the problem. So we may never be able to, without the proper funding anyways. I mean, I guess if you pour money into the problem, they can probably figure it out. You know.
Yep.
You know, have 2 cyclotron beams, you know, one making, I don't remember. Let me look at a periodic table here. I don't remember what the target was supposed to be. Was it? Yeah, I think it's Rutherfordium. How do you say that?
Rutherfordium.
Rutherfordium?
I think I say Rutherfordium. I don't know if that's right. Well,
104, I think, is the target. I think has to be the target now. And if we want to keep using this calcium, I think. But I don't know. So, but anyways, we are kind of at the end of this podcast. So so
is that what you wanted to talk about?
Yeah, that was.
Oh, I didn't know if you had an actual segment.
I don't think so. Talking about our cousin's homework that was the best one. And then, just... Mm-hmm. Yeah, there's not enough information to share about the new coworker yet to talk about that.
But they just started.
They haven't even started. Like I said, they have to go through the testing phase. They could fail, and then we're back to square one. Oh, we had a guy come in today. I'll tell you after. It's oh my god. But I don't really know. But anyways, I don't know. I didn't. It wasn't really. I didn't have anything specific to talk about. I'm deep into chemistry right now. Her asking me about chemistry, and then doing this element series for my shorts.
Yeah.
It's got me thinking. And then Luciteria is running a special this month.
Oh, really?
For 10% off.
Well, the month's almost over. You better hurry.
Yeah, I already did.
You bought a paycheck's worth of stuff?
A what?
I said you bought a paycheck's worth of stuff?
No, not a paycheck, but I bought a good amount.
A good amount.
Yeah, we'll do it after the podcast. Anyways, I'd like to thank you all for watching. Please like, comment, share, and subscribe. New podcasts every Friday, as long as we're not on vacation. 12 p.m. Central Time, and good night.